Welcome back, everybody. I hope you enjoyed your coffee break. So this next session, I'm really pleased to have Colin Penfold from IBM UK from the Hursley Labs, which, as you many of you know, is home to CICS and MQ as well. And just before Colin starts, I was really pleased when Colin wrote to me towards the end of last year, offering to do a presentation on CICS, just give us a CICS security update, because it's so important that, as mainframe security practitioners, that all of these things that are running on the mainframe, these subsystems, the middleware, etc., that they have to be secured as well. So it's really important that we keep up to date with, the what's new security features and changes, etc., that impact security in the subsystems. So without further ado, Colin, welcome to GSE Security Working Group, and the stage is yours, sir.
Okay, thank you very much, Jamie. Yeah, I'm Colin Penfold. I'm the technical lead of CICS Security and have been so for the last decade. I've been in CICS for 30 years and IBM for 40 years, which seems like an age now, rather different times. When I first started in computing at Birmingham University in the 1970s, I was working on a network speed to my computer in Milton Keynes of 110 bits per second. I live in the sticks now, and it has slightly improved, but if the thing goes a little bit dodgy, that's the reason, if the connection goes rather bad. Right, so on to the first four on there. What I'm going to be presenting on is a couple of releases of CICS. I last presented to the GSE Security Working Group in 2018 when I covered CICS TS 5.5 and 5.4. So I'll be covering some new features that we had in 5.6, but most of the presentation will be really new information of our open beta, which came out just over a week ago. So this is fairly hot off the press and gives an indication of where we're going. I've divided the topics up into three sections. I live not too far from Jane Austen's house in Alton. And these aren't three unknown novels by Jane Austen, but these are the sections that I'm going to be talking about sort of new features and functionality in CICS, some checks, health checks, and ways of improving the consumability of security within CICS, and also some new ways of defending things in CICS. Right, so the first topic is about some new features, and these are both TLS features. The first one is going to be talking about SNI, server name indication, which is something that's in 5.6. And the second part is about enhancements to TLS. So first of all, SNI, server name indication. What this is about is where a client can connect to a server which has got virtual hosts on it, sort of thing with the Amazon Web Services, where you have a single server with a single IP address and port. But inside that server, you've got multiple virtual servers that you're trying to host as part of that server. And those, this is something that is relatively new as a standard. And so CICS is now supporting this standard. We're not trying to behave as a virtual host ourselves. That's not really the nature of CICS, but we are trying to support SNI as a client service. So the way we're doing this is we're supporting it if the server is an SNI server. If it's not an SNI server, then we will that's perfectly okay. It doesn't have to be an SNI server, and there's no configuration necessary. So there's no change that's necessary other than having the required version of CICS. Now, although this came out in 5.6 of CICS, because we've got quite a lot of customer demand for this, we backported it to 5.3. So the way that this works is if you've got a couple of clients connecting to two virtual servers, so A server and B server, these are virtual hosts in an SNI enabled server. We have the URI map defining the server in CICS. CICS calls that server, you get the DNS mapping to the actual server. And if you haven't got SNI supported, so this was before we supported SNI, what you'd get back from the server would be the server certificate rather than the virtual host certificate. So you couldn't identify individual virtual servers from that, and you couldn't authenticate virtual servers. What SNI gives you is when you connect to server A, the virtual host A, you will get back the virtual host A certificate to authenticate that. If it's virtual host B, you'd get back the virtual host B. So this gives you a capability to connect to the Amazon Web Services style of virtual hosting at zero configuration cost, which is always the easiest way of configuring security. If you can make something safer by doing nothing, then that's the best way of handling things. So that's a fairly short topic on SNI in 5.6. A larger topic is about TLS 1.3. Now, CICS has supported TLS and its predecessor SSL v3 from very early days. In CICS, I think it was 1.1, it might even been the previous release, we started supporting the web back in the 90s. My predecessor in security was very keen on web support, and so we got that into CICS very early on. Now that was great, but as the web has changed and standards have changed so significantly since that time, and with CICS always endeavoring to support legacy applications, that has given us a number of headaches and a bit of legacy, which I'll go through in these foils. Now, in the past, we've been fairly relaxed in when we supported the new standards. So our support for 1.2 took a few years after the 1.2 standards came in, but this time, because of obviously the greater security interest, we've supporting the latest standards very early on. So the RFC to support for the level of TLS 1.3 came in August 2018. It was supported by ZOS 2.4 when 2.4 came out, and we've got this in the open beta from last week. So TLS 1.3 has got some major changes. Instead of the very large number of ciphers, including lots of insecure ciphers, as was pointed out in the last presentation, there are only 6 ciphers in TLS 1.3, of which 3 of these are supported by the ZOS system. These ciphers are incompatible with 1.2 ciphers. There's no overlapping ciphers that support 1.2 and 1.3. They're more secure ciphers, but the previous ciphers have gone for that standard, which has implications in how one sets things up. There are performance changes. The 1.3 security, the handshake, is just a single handshake, which makes that more secure. Before, you'd got the first part of the handshake, things were in the clear. Now more is encrypted. The algorithms are more secure. Obviously, there is some cost in this, but from our indications so far, provided you've got the right hardware support, there is not a great deal of change in the CPU consumption. There is a change to caching at the moment. The caching algorithm is being looked at. So on to how that impacts CICS. So there's some changes that we've implemented as a result of 1.3. We introduced min TLS level a few releases ago, and that has been changed so that we support now 1.3. You'll notice by default 1.2 is here as the default minimum level for minimum TLS. I'll come on to why that's the reason later on. Normally you'd default to the highest level of security, but things are a little more complicated. We've introduced a new max level TLS parameter, and that's because of the incompatibility problems one has. So rather than defaulting immediately, as we've always done in the past, to the highest level that whoever we're connecting to supports, we say, right, 1.2 is by default the highest level we will connect to. And we've removed some of the previous SIP parameters. The encryption was there as a sort of legacy. That was the old way of specifying encryption, strong, medium, and weak, with that's being rather redundant. Everything wanted strong, and even there, strong meant TLS 1.0, I think it was, which was not exactly strong. And we've removed TLS 1.0 from the ciphers that are supported to try and encourage support for at least a reasonable standard of security. We did have problems when we removed SSL v3 because, as was pointed out in sort of previous presentations, some applications that we're talking to don't support later levels. So this is something when migrating, one has to be very careful about looking at the various levels of software that you are connecting to, because some other software that we're connected to also needs upgrading. Now, ciphers are defined in a couple of ways. They're defined, the main ways that you define them are on the CICS resources, the connection resources, the IPCon, TCP/IP service, and URI map. And there are changes here because when we originally came out with TLS ciphers were defined by having a series of the cipher numbers in an RDO definition. It was the old 3270 RDO type definitions. Now, that was fine at the time, but it didn't work when you get to two-digit ciphers, four-digit ciphers. It was two-digit ciphers were fine. They worked okay on that, but you couldn't mix and match. And so we came up with, in either 5.1 or 5.2, a new mechanism where you could use a ZFS file to define your ciphers. The way we've used that now with the open beta is, instead of when you define a resource, press enter and up pops your cipher numbers that we get, it will now pop up a file, a ZFS file called default ciphers.xml, which you can change to another cipher file with your ciphers in. And as a consequence, you need to have a default ciphers file, obviously, in the place where you locate your ciphers. So this will be a change for some customers because some customers have not really upgraded to using cipher files, but that will be necessary in the next release. We're trying to move away from the old, weaker ciphers. So just to show you that in sort of concrete terms, this is what a CICS screen looks like. You've got the default ciphers there. We will still support those ciphers from compatibility purposes. If you don't upgrade, they'll still work perfectly okay. But we'll give you a warning message now when you use them to try and encourage movement up to XML ciphers. If you move to TLS 1.3, the numeric ciphers will no longer be supported, and therefore we have to give an error message when you try and install things. So that will be clear if you're still using the numeric ciphers. Another change that one's got is the programmatic interface as a web client when CICS is behaving as a web client. Now, in most cases, customer applications will just do a web open and use a URI map in which the resource that you're using has got the cipher file defining the ciphers in there. But we did provide the option many years ago so that you could specify the ciphers in the API command. Now, the only ciphers that you could specify were the numeric ciphers, and therefore this is something that we can't support going forward. So we've taken the unusual step of deprecating an API option. And to help you with this, if you're using TLS 1.2 and earlier releases, if you use that command, we'll issue a warning message to say what the program is that's got that cipher in it. It'll only be issued once per the command being done. You don't have to flood the console. We'll still honor the request. But one thing we've got is there's an API change so that if you try and recompile the program at the latest level of CICS, it won't compile anymore. So that will strongly push you to make a change. Obviously, it will still compile at earlier releases if you need to. When you move to TLS 1.3, we cannot support that option, and therefore it will just be ignored and a warning message will appear. We'll use a URI map if one is available and the ciphers in that. Otherwise, the default ciphers will be used so that it can still be one can still continue. Now, something that I just need to sort of warn about in terms of the upgrade to TLS 1.3. TLS 1.3 is a major change to TLS. And so as a consequence, and this is nothing to do with CICS really, one does need to have a very organized approach to migrating up to TLS 1.3. And we've got steps that I've got there that are clearly documented in the Knowledge Center to indicate that there's a stepwise path that you really need to take to upgrade. You know, that you're upgrading the hardware level, upgrading, sorry, the ZOS level, you're upgrading the CICS level without making any changes, and then convert all of your XML file, all of your ciphers to using the XML files. Make sure the certificates are have got a large enough key size, and then at that stage, does one switch on the TLS 1.3, but you have to go through all those steps beforehand. Otherwise, you could end up with a few problems. So that's the end of the sort of new features that I'm going to talk about. There are other things in CICS TS 5.5, but I think that's the most important ones. Next two things are in the open beta. And these are about changes we're making to improve the documentation that we have with regards to security. And that is related also to best practices and how one tries to encourage best practices and improve the compliance of customer systems. So first about the Knowledge Center changes that we're making. Something that I saw in a survey recently is the average age of the security system programmers is getting younger now. Now, unfortunately for us, that's not due to some sort of magic pill that is making us younger. It's a different reason. The demographics, you know, we're getting people retiring and new people coming in at a younger age. And trying to learn security on ZOS and CICS is not a small task. Remember, sort of many years ago, before the Knowledge Center, you know, when your CICS release came in, it came in with a crate of manuals, and the security guide was a fairly hefty beast. Now, when we were looking at doing a restructure of the information, because this information has been there for some time, and we've added to it, and the information is a little bit more scattered than it was when you just had a security book and very simple 3270 security configuration. Now things are a little more awkward. And prior to trying to do a security restructure, we looked at the information, and there's about 500 pages of security documentation. And that's an overwhelming task for somebody new. So what we're looking at is trying to restructure the security information in the CICS Knowledge Centre to assist with new people into CICS. The terminology that people learn at university is rather different to those of us that have been brought up in mainframe security for the last 40 years. And so we're trying to make sure that those new folk understand what the concepts are, how they apply to a subsystem like CICS, and what you need to do to configure CICS in a secure way. In addition, we got a lot of requests in from application architects trying to understand what CICS supports. And all the information is in there in the Knowledge Centre, but we hadn't in the past aimed it at application architects. So we're restructuring some bits so as to make it easier for an application architect to understand the capabilities of security and how that fits in with the enterprise security. Not everything's on the mainframe, obviously. So how does the whole thing hang together? We're coupling that up with best practice and recommendations. In the past, IBM as a whole didn't like to document something as a recommendation. We felt that was a problem doing that, but we realized that that's not really the right approach. We want to try and encourage best practice. Best practice isn't quite the same as compliance. Compliance is a customer's responsibility to make sure the system is compliant, but we can offer what we see as best practice from seeing around the industry what people use, and recommend best practice where we think that is appropriate. So how will the new Knowledge Centre look? You'll see I've got a link to the open beta site at the end of this presentation, along with some other useful links. Inside that, there are two sections for security. There's the new doc and the old doc. So you'll see that, and you'll see periodic changes to that as the open beta progresses. So the new doc has got an objective to try and make it much more understandable to new joiners. Obviously, those that have seen the CICS for many years are familiar with many sections, but the new joiners coming in cold, we're trying to make it something that they can consume easily. And we're testing this out both internally and externally with some customers. We're trying to increase the how it works type sections to describe the various aspects of security and how they fit into the CICS system. And we're doing things much more pictorially. So every picture says 1,000 words, and we're trying to make sure that that's how we work in the CICS restructure. The way that we're trying to display this information is a much more scenario-based way. We're working with Montpellier, Nigel Williams in Montpellier, has a lot of customer engagements, advising customers on security and performance. And based upon what he's been seeing, we're looking at the most common customer scenarios and trying to give a description of those scenarios on how the security works, and a concrete examples in the scenarios of exactly how to configure things, both from a pictorial way, the high level way, and then low level, how do you configure something? So going through there and giving specific examples of RACF commands or other commands that we can issue to implement security. Dotted about there, as I mentioned, there are best practices and recommendations. So we'll have best practices documented, and those best practices are sort of clear descriptions of what you should do, such as in this case, you should have surrogate security switched on for fairly good reasons. Why it's sensible to do that. And when we specify best practice, those best practices are something, as I'll show in the next section, that we will try and validate for you to try and make sure that systems are configured correctly with those best practices, or you're notified. There may be cases where the best practice doesn't apply to you, but at least you're aware that it's there. In addition, we've got recommendations where we can't validate something. There may be some performance improvements doing something. There may be better ways of doing things outside, and we'll indicate that by just something which is a recommendation. So what you will see in each of these scenarios is a consistent format of describing how things work, how to design it, and how to configure things. What we don't want to do, of course, is lose all your old bookmarks, because many of you sort of have bookmarks to places where you've got information which is really useful. And so wherever you've got a bookmark, it will be redirected to the correct page. And here's an example of the sorts of things that the pages will look like now. So this is a lot of this is based on work that we did with ZOS Connect Security Guide. From the feedback we got was really well liked. And so we're trying to copy that sort of style where you've got a simple diagram explaining the security concepts, where you've got alternatives. Will give a few alternatives on there, and then after this you've got the step-by-step guide explaining where the security fits into this, what sort of tokens flow across, where you have to configure things and stuff like that. So hopefully the newer system programmers, the apprentices, will be able to come straight in and understand what's going on rather than spending their sort of 10-year apprenticeship as would have been the case in the old days. So tied with this is some health checks. So the health checks that we've got on here are all about making these best practices more visible and improving auditability, because auditors, we know, like to have a look at certain things that you're doing. Are you conforming to best practices? Now, some of this came out from work that myself and other members of the security team had done at in looking at customer sites, looking at their configuration for best practice. And we've been looking at those, and there are many cases where we've made recommendations. Now, obviously, it doesn't scale all of us going to every customer site. So this is trying to automate the process that we would have gone through ourselves in trying to recommend best practice. Now, IBM has a tool called the ZOS Health Checker, the IBM Health Checker for ZOS, which is designed to encourage best practice. It's for all of the ZOS subcomponents, and it's been there for quite some time. But in talking to various customers about this, some are quite aware of this and use this information. And many customers we've encountered haven't really taken much notice. The sysadmins haven't seen this option. It's something that's available as an option CK on SDSF, and it's well worth looking at on your systems if you've not looked at that before. The purpose of it is to programmatically check definitions. Now, on ZOS, those are sort of configured on the ZOS system on various files on that. In CICS, it's more a runtime thing because CICS doesn't have definitions on the system. The definitions only apply to a started task. So we check the runtime definitions of any CICS that is running on the system, and it issues success warning and exception messages based upon the severity of whether one's not conforming to best practice or not. And I'll just show a sort of a quick thing on there to show, and other products. RACF have got quite a few checks, as you can see there, recommending certain things, one of which is the password encryption mechanism, the encryption algorithm that's flagged here as exception medium, that the site that we were using here didn't have the KFTS encryption algorithm set. It's got some useful stuff like looking at certificate expiration. So these are what you get on the CK screen. If you select by pressing an S against the one of these checks, you will get displayed information about that check. So this is the certificate expiration, and if you go down in here, you can see all of the certificates that are about to expire within 60 days. Our test system, has got a lot of old certificates on it. Now, CICS came into the health check, started doing health checks in version 5. A hacker came into IBM, into our integrity team, and said he'd got this tool that he was going to present at a hackers conference called CICS Porn as a pen test tool. And what that tool did was, if you've got an unsecured system available, accessible on the internet, then it was possible to get into a 3270 screen and issue commands such as CMT commands or KEKI commands to submit JCL with no checks. Now, this was a badly configured system if you've got that and you're actually accessible on the internet. And I think nobody's ever going to have something as bad as that. But then he showed us where you had some sites which he could access that were available by doing some port scanning. He could find some 3270 screens, accessible production regions that the default user was incorrectly configured, and you could submit JCL, which is very dangerous. I don't need to tell this audience how dangerous that can be. So we put in some checks to warn or alert with exception messages if you've got various levels of misconfiguration, that you allowed a default user, for example, to access CEDAR and install things on CEDAR. That is just really bad configuration. So I expected some customer cases to come back for this, for additional information from customers. You know, sort of, what do I do to configure this? Or even though we described what you needed to do, what's the performance implications? What I didn't expect when I got this was to get a few messages coming back and saying, this message is really annoying me on my system. How do I switch it off? You configure security correctly. That's, you know, what you have to do. But some guys hadn't quite got it. That no, this is your data. You have to secure your data. We're trying to help you say it's not secured. So please try and make sure the data is secured. That was the previous health check we had on version 5. From the work we're doing with the health checker, we're trying to take this to a different level. And this is to really sort of the first step in trying to help compliance, making sure that systems conform to best practice, or at least you are aware of best practice, so can consciously opt out if there is something else, which means you don't need to conform to what the IBM recommendation would be for best practice. You know, that best practice would be to have file security switched on. But you may have the gateway security of transaction security, and in your setup, that is sufficient. So we don't give an exception message, obviously, for that sort of thing. That's more of a lower level information type message. But it's to make you aware of, you should think about, is file security something that is sensible on your system? There are other ways of implementing things rather than requiring file resource security on the system. But please think about that rather than just switching it off because it costs a little bit. So these various new health checks, we've got new health checks which will describe things in terms of overall region configurations, CICS resource configurations, and also ZFS security. ZFS has been around for 25 years now, but some of the system programmers who grew up before ZFS came in had still sort of said, oh, we find ZFS rather difficult to configure, being used to RACF instead, or top secret or whatever. So ZFS was a little bit more difficult. So we've put in a few ZFS checks to try and assist where things have been configured wrong. And often they were configured wrong a long time in the past and just nobody's touched them. So it's to alert you of things like that, misconfigurations that are legacy misconfigurations. So examples of checks are things that I've given on the right there, fairly basic ones that I'd hope that any production region would have. Security on, obviously, transaction security and surrogate security, and also default user no security, in particular to sensitive transactions like CMT, CEDAR, etc. So this is what the new health checker will come out with. The first 3 checks in blue there were the old checks that we'd put in to warn about this hacking opportunity. The new ones are 4 new checks there for different types of configuration. Each of those checks, if you select them, will have a number of individual checks inside them. So if I selected this one, I'm selecting here the region configuration. Inside it, it will report on each region that's got some things that don't conform to best practice. So in this particular case, the first region had got transaction security switched off and had got, which was an exception message. That's a very bad thing. And then there's a warning message for the min TLS level less than the 1.2, which we would recommend nowadays. If you look at those messages in the health in the knowledge center, then we've got a lot more advice, fairly obviously, to describe what you should do about those messages. So that's the end of the knowledge center and health checker section. The last part of it, the last part of the presentation is I call detect and defensibility, about looking at what's going on in security within CICS, and also protecting you from certain sorts of attacks. So the first thing is something that is in the in 5.6. When we did the restructure of CICS, the big restructure that took place in the late 1980s and early 1990s, we restructured the security to create a security domain. Now, in those days, security was a lot simpler because it was 3270 only. You only had passwords and pass tickets. Those passwords and pass tickets were fairly lightweight things. The cost of them was very small. It was something they were secure at the time, but it uses the DES algorithm, which is a lot cheaper than modern algorithms. As a consequence, all security requests went over to a single TCB because we didn't want to stop the QRTCB from being used for security requests. And that was fine, a single TCB for everything to do with security, no problem at all in those days. But things have changed. Things have become much more secure. The algorithms are, as a consequence, rather more CPU intensive. That goes with the security. And there are many more different types of uses of security. You've got not just the password phrases with the old stuff, you've got the new KFDAS algorithm, which is, I think it's about 1,000 times more expensive in CPU by design to make it more secure. It's much more difficult to break into those passwords. We've got the multi-factor authentication mechanism, where you've got some elapsed time that has to be taken into account. You've got Kerberos. Obviously, certificates have been in for a while, but those were new since we implemented security in 1990s. So back in 4.2, we changed so as to use not just the ROTCB, we use multiple TCBs to run security requests on. Now that's great because there's no bottlenecks, but the downside is using more TCBs, and believe it or not, that still consumes 24-bit storage. There's still some stuff that we just can't get rid of. We try to minimize, we've gotten rid of most of it, but there's a few things there. And if there's a bottleneck in the security manager, that could cause problems. If you have to wait for a few milliseconds, it can cause things to build up. And so we are putting in defensive mechanisms to protect against that, so as to limit the amount of concurrent security requests that go through a CICS region. Now, to show that and lots of other information about what's going on in security, we have a lot more reporting of security. We didn't have stats before, so we've got some security statistics and sorts of things that we report on here. At the top, we've added some information about ENF events. So that's when CICS gets notified that somebody's issued a RACF command and a user's characteristics have changed. So therefore, we will flag as old and stale any usage of that, any ACEs relating to that user. Then there's some information that you've got on the usage of ACEs, the security control blocks, and information about successful and failed requests. Obviously, you get within SMF records for RACF information and messages, information about failures, but it's useful also to see that within individual CICS regions. So you can see things about failed authentications, or when you're using fast path rather than a full request, and also about the numbers of successful and failed resource and command and surrogate authentications. In addition to the stats, there is new monitoring information now, so that you can have a look at the performance of various authentications, and those are used in either the old verify password, passphrase, or sign-on interfaces, or there's a new interface called verify token, which is intended to support all tokens, and there are various types of authentication that are done in there. And this gives you performance information on those authentication tokens. Finally, my final topic is about execution protection. Now, when ZOS was, or its predecessor MVS, was created back in the 1960s, all storage was equal in terms of what you could do on it. Obviously, there was protection in terms of the storage keys, so that certain address spaces couldn't read or write to certain parts of data. But all data was equal in terms of whether you could execute code on it. So what that gives you the ability to do, if you have got no limits on whether you can execute storage on any parts of data, it gives you the ability to exploit sort of buffer overflow situations where you can use data storage, receive information in that data storage, and then execute code on that storage. Now, in ZOS, it is very difficult, and CICS, it is very difficult to do that, but it is possible. From what I've seen and what I've tried out, you would need some sort of insider to put in a minimally rogue application on the system. But if you've got that, then you could be subject to data being inserted into CICS, which contains programs, and then execute those programs. So there is the capability for an attack. Back in ZOS 14, there was the ability to separate out storage from executable storage and protected storage and non-executable storage. So I've got examples here of executable storage. So here is something that many of you may recognize as sort of the more common assembler instructions, the load address, loads and things like that. And protected storage is just random storage used for data. What is possible to do is to have data which has got code in it and execute that. Now, as I say, in ZOS 14, there is a new facility which allows you to specify whether data is executable or not. This does require 2.3 plus APARs or 2.4 in order to implement. There are changes here so that the get store command, or the storage obtain, not the get main command, but the get store and storage obtain, can specify whether storage can be executed, whether it's executable storage. In the get store case, you can configure a rule on the system to say whether storage is executable or not. If the hardware doesn't support it, then that option is just ignored. Now, how that impacts CICS is on where we store programs and where we store data. So if we look on the left-hand side in 5.6 and early releases of CICS, you've got these four storage type areas. The RDSA and the extended equivalent of that is for re-entrant programs, which will typically be in key 0, so you can't overwrite them. You've got the SDSA, which is used for shared user storage and also for user key programs. Those are programs which are non-re-entrants that you need to make some updates to. CDSA is for CICS storage, internal CICS control blocks, but also programs which are CICS programs that are non-re-entrant. And finally, there's the user DSA for user key storage. That's normal user storage. Now, we've changed this in the open beta so that you've got two new pieces of two new subpools, DSAs called the PU DSA and the PC DSA and its extended equivalents. So looking at the bottom, you've got the shared user key storage, the CICS and the user key storage. Those are data storage that you cannot execute code on. And the top ones are storage that you can't execute code, you can execute code on. So from the point of view of your normal loaded programs, you'll notice nothing, no difference on that. But if you've got programs, and this more applies to vendors, that have got program code in storage that was getmained, really weird stuff there, but it does exist, then that is going to be something that is equivalent to a buffer overflow type situation. So will be protected against. So what happens if you've got storage like that you're using, and say this would be a buffer overflow type attack? If so, you'll get an OC4 to say that this is something that should not be allowed, and you'll get a particular append that you can see. So you get all an AKES append. So you get all the details to say this is an instruction execution protection type append. There will be occasions where it's necessary to have that code, mostly in vendor code. So if it's absolutely necessary, then we've got a new option on the getmain to say, put this storage in a subpool which allows you to execute code on it. I wouldn't do that for very much code because that destroys the protection. And there are similarly execute options for XPI, glues and chews, and native assembly programs. In order to use this, it's necessary to use the system EIB, because this is, as I say, intended primarily for vendors who often have unusual code, but necessary code for what they're supporting. Now, this is something that would make a quite dramatic change if we just opted in immediately. So there's a feature toggle to enable this. And the purpose of that is, at some stage, this will probably be something that is on by default. Auditors will want it to be on by default to stop you hacking. So we've got to allow for that eventuality. And as a consequence, what we would recommend is people try this out on the test systems, as long as they've got a test system with a Z14 or above, and try it out and see whether all your programs work with it. If so, then you're fine. And we're encouraging the vendors to do exactly the same thing. And once that's all checked out with the vendors and your code, we switch it on and it removes an attack vector. As I mentioned right at the beginning, we've got this open beta, and this is the information about the open beta in the Knowledge Center, a link to that, and also the announcement. If you've got any feedback on the things that I presented, there's a community for feeding back things about the open beta, and also other questions about CICS. The CICS open beta is the site for the open beta. Something that I mentioned at the last GSC meeting that I attended was obviously we're always looking for customer requirements to try and help enhance your security. And somebody at that point sort of mentioned, oh, you know, they go into a black hole. But that is truly not the case. On version 5 alone, we've done 620 separate new customer requirements. So as you can see, and many of those are to do with security. So we're very responsive, hopefully, to try and make your systems as secure as possible. And so we're very happy to receive RFEs about requests for enhancement for any security things that we've either got or should have. And there's a link there to the site. So that's the end of what's new in CICS. So has anybody got any questions?
Thank you, Colin. That was excellent. Any questions, anybody? You use the chat or you can unmute your line. We don't bite, honestly.
It's harder to do this on a WebEx conference.
It is,
or a Zoom
yeah.
conference.
Yes, I know. Okay, so while we're waiting for questions, Colin, I mean, yeah, thank you for a great presentation. So first things first, so 40 years you've done it at IBM, did you say?
Yes.
Wow.
Seems
incredible.
ages now. and I've got 10 years experience before then.
Oh my goodness. Wow. Well, congratulations anyway on your 40th anniversary.
Yeah, I'm not the longest. We've got one guy who 2 years ago celebrated 50 years in CICS.
Wow.
Not in CICS, in IBM.
Oh, okay. Wow. That is
Yes.
long service. Yeah, so it's just a couple of points that I just kind of wanted to sort of pick up on from the, from some of your slides. I mean, I really like the, the security config task, the way that you're moving towards, the younger sort of generation, making it more easier for them to, to go through their configuration steps. That's really nice to hear that. And
yes,
also,
it's something very much that it's an old product, but it runs most of the banks, most of the financial systems, and those of us that work on it, the older generation, want it to pay our pensions, and so we would like people to continue to support it securely.
So there's a motivating factor.
There.
Yes, of course, a motivating factor. Yeah, absolutely.
Yeah, after, when you described the hack in the last presentation, and in the presentation later, it's those things we're really trying to address by making sure customers can easily see how to secure things properly.
Yeah, no, excellent. And that's interesting actually, because I did a presentation last week about it was at a hackathon, and it was around it was kind of an awareness session around how the mainframe basically still runs the world. How we're like as humans are so dependent on the platform, it functioning every day, doing its job, and CICS plays a huge part in that, doesn't it? I mean, there's a couple of things you just mentioned there that.
Yeah, the number of transactions that we have per second is, I saw a presentation, it was about 30 times the combined total of Google requests, Facebook posts and likes and tweets, even with Donald Trump disappearing. When he was there, it's 30 times the total number of all of those put together.
Wow.
So when you think about that, everybody on the planet uses CICS well over double digits per day.
That is phenomenal, isn't it? I'm gonna have to update my presentation to get that in. That is yeah, absolutely incredible. Yeah. The other thing I really like as well is the about the move towards providing best practices and recommendations. And there's an interesting point that I picked up on what you said around sort of traditionally IBM has sort of steered away from that. And my time at IBM, I used to get a lot of clients saying, well, what does IBM recommend that you do? To secure this in the best way. And it was always like, well, we don't really make recommendations. It's kind of based on your security policy, your security standards, and whatever else is driving that, which I think is still true. But it would have been nice in the day if there would have been a kind of a bit of assistance from the vendor. So it's really nice that you're moving in.
Yeah, we're trying to go in. It's sort of there's 3 stages to this. There's sort of compliance, best practice, and recommendations. recommendations are soft things. Have a look at. Best practice is seriously consider this or write down why you haven't. From an auditor's point of view, it would be a case of if you haven't done the best practice, you may have a good reason, but write it down. Why you've got that, so you can show them why you've not done something. And then the compliance is the sort of combined thing of the combined knowledge of the auditor, the customer for their compliance, and us. Sort of what should you have as a combined knowledge that we can't offer firm advice in. That's obviously depends upon customer and their standards. But there's those three levels, and we really do need to get into the best practice of saying, well, we look around loads of customers. What does everybody else do?
Yes.
And why? More importantly, why?
Why? Yeah.
And if you're not doing it, and I've reviewed a number of sites, many are very good, others I've seen, and it's a case of, why haven't you got this? And immediate action taken.
Yes. Yeah.
And it's not because they're deliberately configuring something, is they may have inherited a system. All customers, or many customers, are results of mergers, and it's what you've inherited from your predecessors, and it works. So people are reticent about changing things.
If it ain't broke, don't fix. What's it say? If it ain't broke, don't fix it. Type story.
But that doesn't apply to security.
No, it does not. No, you heard that first, peoples.
Yeah.
Yeah.
You think it may not be broke, but you've just introduced a back door. You've secured your windows thoroughly, but your back door's open.
Indeed. Which kind of leads me on nicely to the CICS CICS PWN tool. It's really nice to see that in there, and also some of the the additional health checks that you're planning. That's really good. I think that the health checker has got really impressive actually these days. The number of checks that are in there. It's like you say, don't switch them off, folks. They're there for a reason. Don't favor performance and cost over security, whatever you do.
It's not really that expensive. The odd millisecond here and there is not going to, compared with the cost of not having them.
This is it. And the final thing I wanted that I picked up on was around the words, and I love these words, designing security, and one example for CICS web service providers. And I love, this word design. It's so important. We use it in extensively in things like system development, application development, but often we kind of don't use it enough in the security world. And it's so important to have this design process that you go through, a systematic process that you go through for designing good security for your mainframe applications.
Absolutely. Because when I started working in computing, security was something that you put on at the end when you'd finished your project, wasn't it?
Yes.
It has to be right at the start, because that's how holes get in. If you think of it later, it's got to be integral. It's security by design, not security after design.
Well, this is it, and this is where, if you look at things like GDPR, they say about they use terms like privacy by design, security by design, and I still hear of cases, the different mainframe shops around the world, where the security practice, mainframe security practice, is still not kept informed of new things, new business activities and stuff that means that there's new applications or extensions to applications that require some kind of security, and it's always still to this day, I think we still have this practice that we're kind of told at 3 o'clock on a Friday afternoon something's gone live and there's an ICH 408 message in the log. Oh, what's that? We just put something live. It's like, well, what's the security requirements for this? And it comes back to design, doesn't it?
Well, I think the GDPR, the privacy thing, it has been a real major sort of success in sort of boosting the importance of security. Because before I sort of consulted with customers and they said, security is an overhead, it's a cost. That's how the executives see it. When GDPR comes along and you've got the EU 7% fine on your turnover, and your executive having to appear on the Today program or whatever, it's a case of that focuses the mind that this isn't an add-on, this isn't a cost, this is part of the business. You get that wrong, and your business reputation goes, and you go.
Indeed, indeed, and that's why I'm quite pleased, like with the sort of likes of GDPR, that we've seen cases, where companies have, have been fined, and I think it is becoming more of a wake-up call to the industry that
Yeah.
you've got to take this stuff seriously, because if you don't, these are the consequences.
Yeah.
And yeah. Okay, Colin. So it looks like we haven't got any questions
Okay.
in the chat, but like I said, folks, keep posting questions throughout the day. If there's something that you think of a bit later for Colin, do post it. If he drops off, then we can always forward that on to him. But thank you so much, Colin, for that. I really enjoyed your session, and we'll have you back at some point for another update, I'm sure.
Okay, thank you very much.
Okay, thanks everyone. So right now we have a break for 15 minutes. So stretch your legs. Have a coffee, and then we will be back at 11:45 with Christian for his forensic session. So I hope you can join us then. And again, don't worry if you can hear us talk in the background. That's just us getting set up for the next session. So thanks everybody. See you in 15.